Okay, so this is the next stage of difficulty with simultaneous equations. If we just compare some of the other ones, we've missed some of these questions out. There was a written question I'd like to have a go at maybe next lesson. But let's just try to compare. So we had, at the beginning, we had 5x and 2x and 3y and 3y. So when we took them away, the 3y's cancelled out. In question 2, when we added them, the y's cancelled out. Y plus negative y is 0. And over here, took them away, the x's cancelled out. Over here, we added them, the y's cancelled. Oh, we didn't do it, but we would add them and then the y's would cancel out. No, we'd take them away and the y's would cancel out because we've got negative 4y. Take away negative. Anyway, yeah. And here we would add them and the y's cancelled out again. Now, in this case, neither adding or taking away cancels anything out because none of them have got a common coefficient, which is the number beforehand. So we've got 2 and 3, we've got 4 and 1, and they don't have, so there's no common coefficient. So adding or taking away doesn't work. There's 2 options available to us. So I'll go through the one that you're more likely to learn at school, and then I'll show you another one that works. And the second one that I'm going to show you works for all simultaneous equations. Nearly all, not all actually, but a lot more simultaneous equations. The first way of doing it, what we do is we start off by multiplying one of the equations by something. Okay, so this is, let's say this is equation 1 and this is equation 2. If I multiply equation 2 by 4, then this negative 4 will become negative 4y. So
why did you multiply by 4?
So if I did multiply equation 2 by 4, if I multiply it all by 4, then I end with 12x minus 4y equals 16. Okay, so just everything's been multiplied by 4. Now you can see we have a negative 4y, but equation 1, I'm going to leave it as it is. And that's just positive 4y. So what I'm doing, instead of doing 1 take away 2 or 2 take away 1, I'm going to do, or adding them in fact in this case, I'm going to do 1 plus 4 lots of 2 basically, or 4 times 2. So I take, so maybe I will do the times symbol actually. 4 times 2. So let's first of all write out 1. So that's 2x plus 4y. And then we'll write out 4 times 2, which is over here, plus 12x minus 4y equals, and then again the right hand side of the first one, 26. And then the right hand side of the 4 times, which is 16 plus 16. So you can see that that's going to cancel out with that, and then the rest of it we can solve as normal. So let's just make sure we understand, was it definitely okay to do that? It might feel as if I've broken some sort of rule, but I've not, because I've just got an equation here. These are 2 equations, they're connected to each other, but they are 2 separate equations. And so, like any equation, let's imagine that I've said that 2a is equal to 9. Then I can multiply this by anything, can't I? So I can multiply it by 3, and if 2a is equal to 9, then 6a must be equal to 27. All right? So basically, this equation is true, and the first equation is true, so I can combine them now the same as I would do even if I didn't have to change it. Okay? So then we continue with it. So I'll stop the video there and see if you can solve it from here.